wanted to pick a universe that looks like the one we have, how will you do it? As with any other recipe, the first step is always to get the ingredients right. But truth be told, getting the correct ingredients is not so easy when you have so many options to choose from. To give a few examples, a universe needs to have a certain shape, a certain expansion history, a gravity theory, and a particle model. Within this, the current standard model of cosmology assumes the following ingredients: a flat universe, an accelerated expansion, general relativity, and a dark matter component. But several studies have shown that assuming dark matter does not work very well when trying to explain some of the properties of galaxies and galaxy clusters. Because of this, the University of Bonn in Germany and the University of St. Andrews in Scotland embarked on a collaborative project to test a universe that uses different ingredients. In this new model of the universe, instead of assuming dark matter, we assume that we have a particle known as a sterile neutrino. And instead of using general relativity, we use a new gravity theory known as Milgromian gravity. This is how a universe made with these ingredients looks like at a scale of 20 million light years. The way to test whether the simulated universe is a good reproduction of the real universe is to look for analogs of some real and well-known astronomical objects within the simulated universe. These well-known astronomical objects that we choose to look for are the galaxies in the local group, mainly the Milky Way and Andromeda. In our simulation, we found two pairs of galaxies that match the total mass, mass ratio, and relative distance of the Milky Way and Andromeda. Therefore, we conclude that our proposed universe model seems like a good candidate to reproduce, at least, some parts of the real universe, which hopefully means that we are one step closer to finding the right ingredients for the universe recipe. I would like to give a big thank you to the Saltire Research Exchange Program for funding my visit to the University of St. Andrews and for making this project possible.
Have you ever asked yourself, what makes a microwave plate rotate? Or, what makes a fan spin its blades to cool us in summer? They all have electric motors. The motor is the one that causes the spinning, which makes everything happen. Now that you know how valuable motors are, I want to tell you some of the challenges that electrical engineers face when designing electric motors. My name is Dewanji Banda. I am a PhD student in the School of Computing at Robert Gordon University in Aberdeen. My research is addressing two of the many challenges that electrical engineers face when designing electric motors. The first one is heat. And the second one is time. Now, let us go through the two problems one by one. When the motor is running in the microwave or fan, heat is produced as a result of friction. And soon, the temperature inside the motor begins to rise. Engineers do not like this heat. The heat makes the motor inefficient, reduces its lifespan, and can cause damage. You don't want that, do you? In my research, I have set out to model heat in the motor using artificial intelligence techniques. My heat or thermal models will help engineers control the heat in the motor to make it more efficient and durable. Now, let us look at the second problem, time. To design a motor, electrical engineers are faced with multiple and often conflicting objectives. Think of a situation where they want to design a motor that uses fewer materials and at the same time one that is efficient. When they try to do that, they realize that as soon as they start reducing materials, to make the motor cheaper, the motor becomes less and less efficient. As you can imagine, a good motor design is one that is a compromise between the conflicting objectives. Now, think of a situation where there are 3 or 4 objectives. This must be so challenging, don't you think? The good news is that optimization algorithms are available that engineers use to identify optimal motor designs. And the bad news is that the algorithms take too long to find optimal motor designs. I am talking of days, sometimes weeks or even months of continuous processing before the computer finds good motor designs. My research is trying to address this problem so that engineers do not have to wait too long to get their designs. In the end, we all want motors that are efficient, durable, and environmentally friendly, and my research is contributing to achieving that. Thank you very much for watching my video.